Hello, science fans. Today, let's take a journey way out into our cosmic neighborhood, far past Mars and the asteroid belt, to visit a real giant. I'm talking about Jupiter, the fifth planet from our sun, and the undisputed king of our solar system. When you think of planets, you might picture Earth, with its blue oceans and green land, or maybe Mars, the rusty red world next door. But Jupiter is something else entirely. It's a behemoth, a colossal world that has fascinated astronomers for centuries, ever since they first pointed their telescopes toward the heavens. It's so big, in fact, that it doesn't just orbit the sun. It makes the sun wobble a little bit. That's some serious planetary power. Imagine all the other planets in our solar system: Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune. Now, picture taking all of them and squishing them together into one giant ball. Believe it or not, Jupiter would still be more than twice as massive as that combined superplanet. It's a heavyweight champion, a true titan that holds a special place in our celestial lineup. Its incredible size and gravitational pull have a huge effect on everything around it, including us here on Earth. It acts like a giant cosmic bodyguard, deflecting asteroids and comets that might otherwise be on a collision course with our home. So, in a way, we owe a big thank you to this distant giant. Jupiter belongs to a special group of planets called the gas giants. Unlike Earth, which is a rocky, terrestrial world, Jupiter doesn't have a solid surface you could stand on. If you tried to land a spaceship there, you would just sink deeper and deeper into its incredibly dense atmosphere. It's a swirling, churning ball of gas and liquid, a place of extreme pressures and temperatures unlike anything we can imagine on Earth. This makes it a mysterious and exciting world to study. Scientists use powerful telescopes and robotic spacecraft, like the Juno probe, to peel back its cloudy layers and understand what's happening inside this massive gassy globe. So as we get ready to dive deeper into the wonders of Jupiter, remember that we're not just looking at another dot of light in the night sky. We are exploring a world that fundamentally shapes our solar system. Its immense gravity helped form the planetary orbits we see today, and its story is a key part of our own cosmic history. From its swirling storms to its dozens of moons, Jupiter is a treasure trove of scientific discovery, just waiting for us to explore it. So put on your thinking caps because we're about to blast off on an adventure to the king of planets. Consider this. So, what's Jupiter actually made of? Well, it's mostly made of the two simplest and most abundant elements in the entire universe, hydrogen and helium. This is the very same stuff our sun is made of. This is why Jupiter is often called a failed star. It's like a star that just didn't get quite big enough to start the nuclear fusion process that makes stars shine. If Jupiter had been about 80 times more massive when it was forming, it would have ignited into a second sun in our solar system. Can you imagine having two suns in our sky? Our whole cosmic neighborhood would be a very, very different place. Because it's a gas giant, its size is truly mind-boggling. You could fit all the other planets in our solar system inside of it, with room to spare. To give you a better idea, let's think about our own planet, Earth. You would need more than 1,300 Earths to fill up the volume of Jupiter. That's like comparing a small marble to a giant beach ball. Its sheer scale is hard to comprehend, and its massive size gives it an incredibly powerful gravitational pull. This gravity is so strong that it tugs on everything that passes by, from comets to asteroids, and even its own large family of moons, which we'll get to later. The colors of Jupiter are another one of its most famous features. When you see pictures of the planet, you see beautiful bands of white, yellow, orange, and brown clouds. These colors are the result of different chemicals in its atmosphere reacting with sunlight. The bright white zones are areas where gas is rising, and the darker brown belts are where gas is sinking. These chemicals, called chromophores, are what give Jupiter its distinct painterly appearance. Scientists are still working to figure out exactly what all these compounds are, but they believe they contain sulfur, phosphorus, and maybe even some complex carbon molecules. It's a beautiful chemical mystery. Another thing that makes Jupiter special is its incredibly fast rotation. While it takes Earth 24 hours to spin around once on its axis, completing a full day, Jupiter does it in less than 10 hours. This is the fastest rotation of any planet in our solar system. This rapid spinning action causes the planet to bulge out at its equator and flatten at its poles, so it's not a perfect sphere. This super-fast spin also contributes to the planet's wild weather, including its powerful jet streams and massive swirling storms. It's a dizzying, dynamic world that is constantly in motion, a true spectacle of planetary physics in action. When we look at Jupiter, we're not seeing a solid surface, but the tops of its clouds. The planet's atmosphere is a chaotic and violent place, with winds that can reach speeds of over 335 miles per hour. That's about 540 kilometers per hour. These winds are whipped up by the planet's fast rotation and the heat bubbling up from its interior. Imagine hurricanes on Earth, but much, much bigger and lasting for years, or even centuries. The entire planet is covered in these swirling weather systems, creating the beautiful bands and vortices that we see in photographs. It's a permanent, planet-wide storm. The most famous storm in the entire solar system is on Jupiter, and it's called the Great Red Spot. This isn't just any storm. It's a gigantic, crimson-colored cyclone that is wider than our entire planet, Earth. Scientists have been observing this massive storm for over 300 years, ever since the first telescopes were powerful enough to spot it. While it has been shrinking over the last few decades, it remains a powerful and mysterious feature of the planet. It's an anticyclone, meaning it spins counterclockwise, and its winds at the edge can rage at incredible speeds. It's a weather event of truly epic proportions. But the Great Red Spot isn't the only storm on Jupiter. The planet is covered in them. There are countless smaller storms, some white and some brown, scattered across its cloudy surface. In recent years, NASA's Juno spacecraft has given us an even closer look at Jupiter's poles, revealing clusters of giant cyclones arranged in geometric patterns. These storms are each the size of the United States and are locked in a strange, stable formation that scientists are still trying to understand. It shows us that even after centuries of observation, Jupiter still has plenty of surprises in store for us. So why are these storms so long-lasting? On Earth, hurricanes lose their power when they move over land, but Jupiter has no land to stop them. These storms are fueled by the planet's internal heat and can rage on for an incredibly long time. The Great Red Spot, for example, is like a hurricane that has been spinning for centuries without anything to slow it down. Studying these massive weather systems helps us understand the complex physics of atmospheres on a grand scale, which can even help us better understand the weather patterns here on our own planet. It's a natural laboratory for atmospheric science. Jupiter isn't just a lonely giant floating through space, it's the center of its own miniature solar system. As of today, astronomers have confirmed that Jupiter has an incredible 95 moons orbiting it. That's a lot of cosmic company. These moons come in all shapes and sizes, from tiny captured asteroids only a few kilometers across to massive worlds larger than the planet Mercury. Each one is a unique destination with its own story. Some orbit in the same direction Jupiter spins, while others go the opposite way, suggesting they were captured by Jupiter's immense gravity long after the planet formed. Among these dozens of moons, 4 stand out. They are called the Galilean moons because they were first discovered by the astronomer Galileo Galilei in 1610. Their names are Io, Europa, Ganymede, and Callisto. This discovery was a huge deal because it showed that not everything in the universe orbited the Earth, which was a major shift in our understanding of the cosmos. Ganymede is the largest moon in our entire solar system. Io is the most volcanically active body we know of, covered in hundreds of volcanoes spewing sulfur. And Europa is especially exciting because scientists believe it has a vast liquid water ocean hiding beneath its icy shell. Here's a fun fact for you. Jupiter has rings. When people think of rings, they usually think of Saturn, but Jupiter has a faint ring system of its own. They are much harder to see because they are made of tiny dark particles of dust, likely kicked up from its inner moons by micrometeoroid impacts. They were so faint, in fact, that we didn't even know they existed until the Voyager 1 spacecraft flew by in 1979 and took a picture looking back toward the Sun, which backlit the fine dust. So, while they're not as flashy as Saturn's, our solar system's biggest planet does have its own set of rings. Learning about Jupiter is incredibly important. It's a key piece of the puzzle to understanding how our solar system formed and evolved. Its powerful gravity has shaped the orbits of other planets and protected Earth from countless impacts. Studying its intense storms helps us understand meteorology on a massive scale, and its moons, especially Europa, offer some of the most promising places to search for life beyond Earth. Jupiter is more than just a big, beautiful planet. It's a scientific treasure chest. By exploring it, we learn more about the universe and our own special place within it. Science is cool,